Have you ever wondered how VLANs spanning multiple switches are configured? As you navigate the labyrinth of network engineering, you've likely encountered this challenge. Well, wonder no more. This complex yet vital aspect of network configuration is a key component in creating efficient, secure, and scalable networks. It's a puzzle, sure, but one that we'll piece together. So strap in, brace yourself, and prepare to delve into the world of VLANs spanning multiple switches. Today, you will learn how to configure VLANs that span multiple switches. To understand the configuration of VLANs spanning multiple switches, you first need to grasp the concept of a VLAN. So what is a VLAN? A VLAN, or Virtual Local Area Network, is a concept in networking that allows you to segment a physical network into multiple logical networks. Think of it like partitioning a hard drive. You have one physical drive, but you divide it into separate sections, each acting as its own independent space. The same goes for a VLAN. You have one physical network, but you can slice it into separate, isolated networks. Each of these networks is a VLAN, and they can all coexist on the same physical infrastructure but operate independently. But why would you want to do this? Well, there are several reasons. One is security. By separating different types of traffic into different VLANs, you can better control who has access to what. It's like having separate rooms in a house for different activities. Another reason is to reduce network congestion. By segmenting the network, you can limit the amount of broadcast traffic that each device sees, which can significantly improve network performance. VLANs also offer greater flexibility. With VLANs, you're not constrained by the physical layout of the network. You can group devices together logically, regardless of where they're physically located. This makes it easier to manage the network and adapt to changing needs. Now, a VLAN isn't just confined to a single switch. It can span multiple switches, creating a larger logical network. This is where things get a bit more complex, as we need to ensure that the VLAN information is consistently maintained across all the switches. But don't worry, we'll get into that in the next scene. Now that you're familiar with VLANs, let's delve into how they span multiple switches. This is where we'll explore the concept of trunking, which allows us to carry traffic from multiple VLANs across a single link. But that's a topic for another scene. For now, just remember, VLANs are all about creating separate logical networks within a single physical network. Before we move to multiple switches, it's important to understand how to configure a VLAN on a single switch. Imagine you're setting up a network for a small business. You've got a single switch, and you want to separate traffic between the human resources department and the rest of the company for security reasons. This is where VLANs come into play. The first step is to access the switch. We'll use the command line interface, or CLI, which is a text-based interface used to configure and manage network devices. Once you're in, you'll want to enter the enable mode. This is as simple as typing enable at the prompt. Next, you'll need to access the global configuration mode. This is where we'll create our VLAN. Type configure terminal, or conft for short, and you're in. Now, you're ready to create your VLAN. Creating a VLAN is done with the VLAN command, followed by the VLAN number. For our example, we'll use VLAN 10. After hitting enter, you've created your VLAN, but it's a good practice to give it a descriptive name. Let's name ours HR. We do this by typing name HR. So far, so good. But our VLAN isn't much good if we don't assign any ports to it. Let's assume that the HR department is connected to ports 1 through 5 on our switch. We'll need to assign these ports to our new VLAN. To do this, we'll first exit back to the global configuration mode by typing exit. Then we'll enter the interface range configuration mode by typing interface range fast Ethernet 015. This allows us to configure multiple ports at once. Next, we assign these ports to our VLAN with the switch port access VLAN 10 command, and there you have it. You've just configured a VLAN on a single switch. Of course, this is a simplified example, and real-world scenarios may require additional steps and considerations. But you've got the basics down, and that's a great start. With that knowledge in hand, you're ready to tackle the configuration of VLANs across multiple switches. Configuring VLANs spanning multiple switches is a critical skill for any network engineer. To understand the process, let's first break down what we're doing. Essentially, we're creating a virtual local area network, or VLAN, that spans multiple switches. This means that devices connected to these switches, regardless of their physical location, can be part of the same logical network. So, where do we start? Well, we begin by configuring VLANs on each individual switch. This process is similar to configuring a VLAN on a single switch, which we've already covered in our previous scene. Once we've set up VLANs on each switch, it's time to connect these switches together. This is where trunk links come into play. Trunk links are network lines that carry multiple signals simultaneously. They connect the switches together, allowing VLAN information to be shared between them. Now let's talk about the 802.1q protocol. This protocol is essential for VLAN trunking as it tags each frame with a VLAN identifier, or VD. The VID tells the receiving switch which VLAN the frame belongs to. This way, even though multiple VLANs are using the same trunk link, the frames can be directed to the correct VLAN. Let's imagine we have 3 switches, switch A, B, and C. We've created VLAN 10 on each of these switches. Now we want devices on VLAN 10 across all 3 switches to communicate with each other. First, we connect the switches using trunk links. Then we configure the trunk links to use the 802.1q protocol. This way, when a frame from VLAN 10 on switch A needs to reach VLAN 10 on switch B or C, it's tagged with the VID for VLAN 10. When switch B or C receives the frame, they read the VID, know it's for VLAN 10, and direct it accordingly. Now, remember, the 802.1q protocol doesn't just work with one VLAN, it can manage multiple VLANs across the same trunk link. So if we also had VLAN 20 on switches A, B, and C, the 802.1q protocol could handle frames for both VLANs simultaneously. And that's it. That's how you configure a VLAN that spans multiple switches. Keep in mind, while we've used 3 switches in our example, this process can be extended to as many switches as you need. As long as the trunk links are set up and the 802.1q protocol is configured, you can create a vast network of interconnected VLANs. And there you have it, a VLAN spanning multiple switches. But how do these switches connect to each other? Let's find out. Interswitch connectivity is the backbone of any large network. This is where the magic happens, where individual islands of switches unite to form an integrated network landscape. To appreciate the concept of interswitch connectivity, let's imagine a bustling city. Each switch is like a building housing various floors, our VLANs. Now, these buildings are not isolated. They are connected by roads enabling traffic flow between them, similar to how our switches are interconnected. This network of roads is our interswitch connectivity. Interswitch connectivity is vital for 2 reasons. Firstly, it facilitates communication between VLANs across multiple switches. Without this, a VLAN confined to a single switch would be like an island, isolated and unable to interact with others. Secondly, it enhances the efficiency and resilience of the network. By providing multiple routes for data, it ensures that a failure in one part doesn't paralyze the entire network. Let's delve deeper into how this works. The primary tool for interswitch connectivity is the trunk port. A trunk port is a conduit that allows traffic from multiple VLANs to travel between switches. It's like a multi-lane highway connecting our buildings, where each lane represents a different VLAN. But how does the network keep track of which data belongs to which VLAN as it travels across the trunk link? Here's where the 802.1q protocol comes into play. It's like a traffic cop, tagging each data packet with a unique VLAN ID as it enters the trunk link. When the packet reaches its destination switch, the 802.1q tag is removed and the data is delivered to the appropriate VLAN. In essence, interswitch connectivity, trunk ports, and the 802.1q protocol work together like a well-oiled machine, ensuring smooth and efficient data traffic between VLANs across multiple switches. By understanding interswitch connectivity, you can effectively manage and troubleshoot networks with VLANs spanning multiple switches. So let's continue our journey into the fascinating world of network engineering, where every switch, every VLAN, and every trunk link plays a crucial role in building this digital metropolis. Today, you've learned some critical concepts in network engineering. We've delved deep into VLANs, understanding their fundamental role in network segmentation. We explored how to configure them on a single switch before tackling the more complex task of spanning VLANs across multiple switches. We also uncovered the essentials of interswitch connectivity, focusing on trunk ports and the 802.1q protocol. Keep practicing these steps, and soon you'll be a pro at configuring VLANs spanning multiple switches. Until next time, keep networking.